Hey guys, so today we're going to solve Leetcode problem number 380, insert, delete, get random, O1. And as always, this is my first time seeing the problem and I'll be solving this problem live. So the problem statement is as follows: design a data structure that supports all following operations in average O of 1 time. Inserts and so we have to implement three methods: insert some value, remove some value, and get random. So for insert, we have to, and what that method's supposed to do is it's supposed to insert an item val to the set if not already present. Remove val will remove an item val from the set if present, and get random returns a random element from current set of elements. Each element must have the same probability of being returned. So for example, we see this example here, how the class is initialized. So we have some object called random set, and insert is being called, inserting 1, remove 2. Remove will return false if the value does not exist. Insert will return true if it was inserted successfully, and random will return the either 1 or 2 that were inserted previously randomly. Okay. Okay, so let's talk about implementation. So let's go through each one of these methods one by one, right? So we have insert some value, we have remove value, right? And we also have get random. Okay. And based on the example here, insert will return some boolean value that indicate whether the operation was completed successfully. It'll return true if success and false otherwise, right? Same with remove, true, success. And success in this case means that the value either doesn't already exist within the set, right? If the value already exists within the set, then we return false. Same with remove. If the value doesn't exist within a set, then it returns false. If it does, then remove that item and return true. Okay. And get random will return some values within the set randomly. It'll pick any one of the values within the set randomly and uniformly, right? Some integer, so it'll return some integer, some random. So now the question becomes, what about empty set, right? What do we return? So let's read this problem statement and see if we can come up with any assumptions for that. So what happens when the set is empty? What does return get random? What does get random return? Okay, so let's put this under a set of assumptions that we have to make, right? What about, so the first one being, what about empty set, right? What does get random return? So that's the first question that we have here. Also, one of the requirements is that on average all of the operations have to operate in O of 1 time, right? Or of some constant time. Right? So let's make the comment nice. And as always, I like to write down the problem specification, and I like to break it up into some sort of summary within the comment section, so that way my brain has some time to process the information. Okay. So to answer this question, I'm just going to assume that it'll return none, right? In this case, since we are returning, if the set is empty, actually, let's see. Ideally, we would want to raise an exception. So actually, let's do that, right? If the set is empty and GetRandom is called upon, then we'll raise an exception, something like raise exception empty set. Something that we see commonly within a queue or a stack data structure, right? When the queue or the stacks are empty, and whenever we call pop on those empty data structure, we get some sort of exception from them. Okay, so now let's get to the meat of this implementation, right? So for insert, we have to be able to insert in a constant time, right? So doesn't seem like anything is stopping us from using some sort of a hash map or a set, right? In Python, what we could do is we could use set as our internal data structure. So with this with set as our internal data structure, insert will be O of constant as well as remove. Also checking to see if an element already exists within a set. So any sort of exist checks will also take constant time. Okay, so that covers our insert and remove operations. What about GetRandom? Okay, so this one is a little tricky because we have a set. A set is unordered. Because we are storing the integers into a set is unordered, meaning that, let's say if we were to generate some random indices, we're not guaranteed to be getting the same element from a set, and so we have to somehow maintain order information. And this is achievable by okay, so instead of using a set, we'll use hash map, where the value will be the number itself, and where the key is the number itself, the value, and the value will be an index that points to a list. So now instead of having one internal data structure, we'll have a hash map. We'll maintain a hash map where the key is the value, and where the key is the value that we insert, and the value of that hash map will be an index of the list, right? So as I was saying earlier, we'll maintain order information by maintaining a separate data structure, a separate array, list of numbers of values. And how would that work? So let's say let's get into some sort of examples, right? So let's say we have values 1, 2, and 3, right? So let's say within our set we have value 3, 2, and 1, right? So when GetRandom is called upon, we'll be generating some random values between 0 and 0, 1, 2, 0 and 2, right? And because we have the values stored within this set, within this list already, actually I just realized something. A list will not be sufficient for us here. Let's see. Because removing and inserting will no longer be O of one time unless that list is a dynamic list, which means that amortized insert and remove will be O of constant on average. So we're using a dynamic list will still get us to an average O of one time. So and Python by default and Python array by default is a dynamic array, which just means that the array is dynamically allocated whenever we hit a capacity, a threshold, meaning when we hit the maximum size of the array, right? The backend of Python will automatically doubles the size every time, or either do some sort of optimization to give us that constant amortized insert runtime. Okay, so getting back to this example, so let's say because we are maintaining a dynamic list of array, so insert will be easy. Let's see, this is getting a little tricky. Okay, so maybe using a list is not a good solution because remove is difficult, right? Downside. Even if we are able to retrieve a random element from a set by generating random indices and then using that index to get that random element, that will be constant time. However, whenever we need to call remove, remove will take linear time because we have to search for that element. And if for whatever reason we are removing randomly, there will be a lot of holes within the array, the list. It'll be hard to fill the gaps, right? If the remove are not contiguous, then we'll have a lot of essentially holes within the array, meaning that we have a lot of gaps within the middle of the array. And so now that I think about it, it's not that easy to maintain ordered information. It's not suffice to use a list or an array to maintain ordered information because remove is so difficult. Okay. So I still like the idea of having a hash map to store our values, uh, because inserting, remove, and checking if a number exists or not are constant. Okay, so what about using a linked list, right? Let's see, can we use linked list? The down, so no, it's not quite. So it's not quite there yet. We cannot get to a random node within a linked list. It'll take O of n to retrieve random index. If we were to generate a random index, then it'll take O of n for us to traverse the list. Unless we can look it up within the hash map somehow. But as I was saying earlier, the hash map only maintains, let's see, okay. Let's see, design a data structure that supports our following operations in average or constant time. Insert an element. So we have insert, remove, and exist down, all of which are constant time in time complexity. However, we are having trouble implementing implementing GetRandom, right? So, and a typical way of getting some sort of random information is by calling some random function to get random values between some range, right? And that's typically how we would do it if we want to get a random element within a set, right? We want to randomly and uniformly, meaning equally likely, picking any values within a set. We want to do that randomly. Let's see. But in order for us to be able to retrieve that random index, we have to somehow maintain index information. And that is why initially we were going to the route of maintaining another array and storing those values in an ordered manner. However, removing is difficult. It takes O of n to remove, as well as holes in array. Let's see, anything else we can do here? What about maintaining another hash map? Is that possible? let's see. What can we do here? Remove. Okay, so currently I cannot think of any other ways of maintaining ordered information besides using a list. So at this point in time, I would probably settle with using a list and accept linear time for remove. So at this point, I would try to come up with a way to optimize remove from a list, right? So let's say we have a list of information here, right? 3, 2, and 1. So let's say we randomly remove 2, right? We call remove on 2. So now, how do we fill in the gap here? Right? I mean, one way of doing it would be to move all elements to a new array. So that would take off n time. Instead of making this complicated, another way of solving this problem, because we still have to go through this route anyway, what we could do is another alternative is converting the set to a list, right? So every time we do either an insert or remove, okay, actually let me take that back. Anytime GetRandom is called, we'll update our internal list by converting the entire set to a list when GetRandom is called, right? If there are any changes, right? So this is what we do. When GetRandom is called, we'll update internal set, internal array. If there are any changes, and by doing so only when there are changes, hopefully on average our GetRandom will be constant, right? So on average our GetRandom will be constant. However, if the worst case comes when when there are a lot of changes to the sets, meaning that inserts and remove are called constantly, the worst case will be O of n time, because we are constantly updating internal list. Okay, so let's settle with that. Okay, so we'll do that. So we'll implement that approach. Okay. So let's get to coding. So as I was saying earlier, we'll have some internal hash map. Actually, we're not using a hash map anymore. We only need to store a set, right? We don't really care about anything else but the values themselves, so we can just use Python set. Let's call it initialize set, and we'll also have some internal list, right? We'll initialize it to an empty list, and we'll also have some flag called change, right? We'll set change to false, and whenever insert or remove are called, change will be set to true, so that we can use this flag to notify GetRandom that we have to update our internal list. Okay, so the first thing, so let's implement our insert. The first thing that we do is we checked if value exists within a set, right? If val is in, return false. Don't need is, we need, that's all we need. And then out here, if we got past this check, the first thing we'll do is we'll set the flag change to true, and we'll also add our new value to the internal set like so, and we'll return true in the end. We will do the same with remove. If val in self.set, else we return false. The first thing we'll do is we'll set the flag to true as well. We'll remove val, and we'll return true at the end. Okay, so this is where things may get a little more involved here. So the first thing we have to do is we have to check if there are any changes, right? If changed, then we'll update our internal list. Let's see what we do. Okay, and in Python we can simply call list upon the set, and really that's all we have to do to convert from a set to a list, right? Okay, so now, and after updating our internal list, we'll set the flag back to false, meaning that we have retrieved the change. Okay, so now the next thing that we do from now is we have to generate some random indices, right? So let's look that up quickly. I don't remember off the top of my head. Python generate random integer. Okay, so we'll import, let's see, random. Okay, so we do import random. Let's see. Let's quickly look at the implementation. So typically whenever you call random, you'll get, okay, this is how you, right, so you get some values between 0 and 1, right? Typically okay, So now all we have to do here is we can simply call random. Okay, so what we want here is we want to call random. This is how you do it, which will give us some values between 0 and 1. And what we want to do as well is multiply that random value by the size of our list. Okay. And let's see, why does that work, right? So let's say we have some values like so, and we'll times it by 4, right? Let's see. The reason why I want to use the random generator to generate 0 to 1 is because I want to refresh my memory on how to generate integers from decimal, from a small random values between 0 and 1. Let's see, just want to refresh my memory on that. I think you multiply it by the size, right? Let me look that up. GetRandom integer. Remember I've done it in C before. Let's see. I think you multiply it by an integer, or you do a module on the integer itself. Interesting. Okay. Actually, I'm just going to do some quick experiments here. Okay. You know what? Let's not do that for now, and we just use randint. Let's see. So if I remember correctly, randint will give us some values from let's see, size is 10. Okay, I think that's it. Let's see, let's read this documentation. I'm trying to see if high value is inclusive or not, and doesn't seem so. So we can simply just pass in and how do we import this? Yeah, let's go back to it. Okay, so we just do that. Random.randint values from like so, and we'll return self list index, and that should be it. Oh, built-in function has no attribute randint. Okay, it's just import. So let's do that. Okay, so right, this will never be the same only because it's a random value, right? Let's see, how does the test case work here? So we are randomized, we are initializing the set, insert, remove, insert, and then get random. Initialize, insert, what was it? Insert, remove, insert, insert, remove, insert, get random, insert, get random. Okay, and that should be it. So let's see if this code is good. Index out of range. That's not good. Okay. So let's fix this. Let's see if this code works for this example. Let's run this. Right, so 76. Okay, we don't need that. Oh, right. The other thing that we have to do is let's see. Right, if the set is empty, then there's nothing to be returned. Okay. So let's just do a quick test here. Okay, we'll see. So every time GetRandom is called, we'll get the size. Okay, so std out. Interesting. So it is inclusive of the maximum value here. So we have to fix that. Okay, I think that should help fix the problem. Okay, so submit this code. Okay, so the solution seemed to be good enough to be submitted to Leetcode system. Okay, thank you for watching and see you guys next time.